All right, on to the next one. Gregory and Joe for Calamari API hardware storage, all the things. So, Gregory, you want to start us off?
Yeah, thanks, Patrick. Can you guys all hear me?
Yep.
Gotcha.
Great. So this session is going to be about the planning and implementation of a hardware API for Calamari. And kind of the overarching motivation for doing this is to provide Calamari with the ability to know about the underlying storage behind OSDs so that when things happen to that hardware, we can figure out what the impacts are to the cluster and help advise for root cause analysis and make the life of storage administrators easy so that they can identify the appropriate hardware to replace and know what to replace it with and whether that hardware is under warranty or has recalls or any of that sort of stuff. So basically, it's the full cycle of I know something's wrong with the hardware. How does it affect my cluster? And the other side, I know something's wrong with my cluster. What hardware is likely the culprit? So to that end, I'd like to direct your attention to the Etherpad, which is probably the easiest way to consume this data, because I've pasted in some of the potential API endpoint and fields. So I want to discuss those. So the setup here is basically, in large distributed systems, events are always happening. And we care mostly about, the causes of these things rather than just a large stream of events, because we want to give the quality of information over just the noise of a distributed system. Things always fail, and that's to some degree acceptable in the Ceph world because of the way that it's designed. So let's imagine for a minute that an OSD goes down and you know that it's in some host, but what drive is that? And is that a software failure or a hardware failure? What do you replace it with? How long has it been failing? So those are some of the questions I want to try and answer with this API. And you can see that we've got kind of a generic listing endpoint on line 27, API v2 hardware storage. And on 39, a specific detail for the same, which is you've picked out one piece of storage by SCSI WWID. And so these are just kind of a list of proposed fields that we think, Joe and I think, are useful. And we'd love to hear some feedback on whether there's anything we're missing there. And then there's a list of questions that I'll go over. And if anyone feels strongly one way or another, we can go ahead and log some answers and have some discussion about it. Does that sound fair?
Sounds good to me.
Excellent. And so, of course, getting caught up in the excitement of CDS, I realized that I wanted to make an announcement at the beginning of this and totally just plowed through it. There are packages for Calamari available on download.ceph.com/Calamari. At the top of the Etherpad, I've got some questions I expect to get about this and some answers about those questions. And you can read them, and I'll kind of answer them here again with my voice, which is what packages. And specifically, it's the packages that till now you've had to build if you've wanted to interact with Calamari. So Calamari Server, Clients, which is becoming Romana, and Daemon, which is a package that we have a fork of that hasn't made it upstream. So that's great. Got packages. What do I do with them? Well, it turns out we have a read the docs page for Calamari, and it has guidance on how to install. I've provided the link in the Etherpad. This stuff is also available on the GitHub README, so that'll be front and center for anyone who checks out the project first. So that's all well and good. You can see if you actually go to that URL with the packages that there's stuff available for CentOS and Ubuntu. What's the plan going forward? So we've released the packages from our latest stable version, and that's a point in time and it's a start. And we want to go ahead and get some nightly test suites running against these packages and some public-facing build infrastructure so that we can go forward and start filling out the like the master branch build packages and other releases. So this is a very small start, but it's an accomplishment nonetheless. And I want to thank Dan Mick for his work in getting these out there. So then you might say, well, CentOS and Ubuntu, those don't support my favorite distributions. When's that going to happen? My answer to you is when volunteers emerge to lead the effort. I've planned to do Fedora 21 Plus, and I'm going to be making progress on that the rest of this year. But if you have strong feelings about distributions such as SUSE or Debian or anything else that I'm forgetting, feel free to suggest what we can do to make that better and how we can get packages for your distribution.
Do you mind if I come in with a question?
Absolutely, John. Please ask away.
So when you say do packages for Fedora 21, do you mean rebuild the big /opt package for Fedora 21, or do you mean like do packages that would be suitable for going into Fedora?
I mean the latter. I'd like to start moving away from opt Calamari, and so I think if I'm going to sink any real effort into this, that it's going to mean getting it so that Fedora actually accepts these packages. They're not just packages that would install on Fedora. Does that make sense?
Yep, that's the right answer.
You didn't know there was a right answer.
I knew there was a right answer. Okay, so if there's no more questions about packages, which I'm really excited about, let's go ahead and go back to the hardware API. So from feedback on the mailing list from John Spray and others, we've gone ahead and tried to include some more information available in the hardware endpoints. And mostly, you can see by the URL structure that we're targeting storage. I've left it kind of open-ended. The namespace is hardware storage. So maybe that's a prelude to we might be trying to do something with hardware networking. But for right now, we're focusing on storage. And we're choosing to identify these by the SCSI WWID. And I guess the first question is that the right persistent identifier for storage?
It's reasonably close enough given what the storage controllers do, at least speaking from an HP perspective and knowing how the Avago controllers work too. That's reasonably standards based.
What about PCI Express devices? Do they give you a WWID?
Do the devices themselves give you a worldwide ID?
Yeah, like if you've got a PCIe flash device?
That's a fair question. I mean, it would be probably the way they've implemented it is that there's basically a faked out controller in front of the device, and it's just a single controller to a single disk. But that would be worth following up on because, yeah, if you don't have that for, say, a Fusion IO card or something else NVMe, then this breaks down for that.
Okay. Yeah. So I've logged that question in Etherpad. I don't have a good answer to that either, but it's definitely worth answering.
Yeah, that tends to not be my background. I spend more time on the smart array controllers in general. So hard drives, SSDs, that's what I consume in general. But that's something we need to think about going forward for accelerators. And even NVDIMMs, really.
Yeah,
indeed.
Definitely a new world of storage out there. It's evolving. Okay, so one of the other big questions that comes to mind when designing this API endpoint is, well, we're trying to kind of straddle the boundary of the endpoint provides things that are human readable, but also machine consumable. And one question that comes to mind is, currently the architecture of Calamari is that we store all this data about the cluster in memory, and we serialize it to a persistent store in the background, mostly for purposes of crash recovery. And smart, for example, the smart data is quite verbose. And so kind of the question I would ask is, do you think that the largest Ceph clusters we know about would raw smart data for the most recent check on all those OSDs, would that overwhelm a typical Calamari installation? So I guess there's a couple embedded questions in there where what do you assume to be a typical Calamari installation? And my answer there would be, well, you could think of it on terms of, you wouldn't expect it to be beefier hardware than a monitor per se. So
Right.
do we have any kind of parameters about that we'd like to talk about?
Just from my perspective, I don't have any better input than you do about what a standard Calamari server would look like. So, but yeah, to your point, my speculation is that we would probably want as much of the smart data as we can get. If it does overwhelm a standard installation, the way we store information for Calamari today, then we probably want to push it down to into a log file somewhere so people can go back in history and take a look at trends. It's hard to tell what's going to be useful for everybody.
That's a fair observation, and it definitely brings to mind an old discussion that John and I had was that Calamari mostly cares about the current state. What do you do with historical data? Currently our answer is we try to provide really fast access to, get information about cluster state by providing this architecture. And maybe this is one thing where we would want to explore serving data from a persistent storage and cache where necessary. So the idea being that you have a kind of slower endpoint where you can get a lot more historical data. So maybe that you're not grepping log files, but you're using an endpoint that you know is going to return slower responses. What do you think about that, John?
So if you look at the amount of data that you're already storing per OSD, storing an extra 20 smart values is shouldn't be a big deal, but you'll probably need to be a bit careful with your database schema. So like it might be tempting to normalize that and have like a table that has smart type, smart value for each OSD. That might give you, worse performance than if you just denormalize that and have a value field in a table that gives you all the smart data in one go. When it comes to historical stuff, the nice thing about smart data is it doesn't vary very rapidly, at least the parts you care about don't. So, it's not something you need to go and poll every 10 seconds. It's more of a, I don't know, it's measured in minutes and possibly hours, the frequency with which, you need to check it. So I would think it would be a reasonable goal to store it all.
Mm-hmm.
I don't think you should throw away data if you can possibly avoid it.
Sure.
And as for whether a normal server will hold up, I mean, the starting point is to synthesize, 10,000 hard drives worth of data and, run that on your laptop. And if it works on your laptop, great. We can stop worrying about it.
Yeah, that's fair.
The other concern I have about smart data is like John said, it is something you really don't need to pull all that frequently, but that doesn't mean people don't try to pull it all that frequently. So we probably need to think about whether we want to put in some mechanisms to protect people from themselves effectively. Maybe have a cache somewhere in Ceph or even somewhere in Calamari where if they pull the same data within a certain period, be it less than a minute or whatever, they get the cache data instead of going through the device and actually issuing another smart inquiry.
Yeah, and to a large extent, that's the way that the architecture is designed right now, which is all GET requests are serving from the Python memory, so which is effectively a cache around that data. And we schedule all our questions to the state of either the Ceph cluster or the hardware in the background. So there's only one endpoint in my mind that doesn't obey that principle, and that's the CLI endpoint, which is basically a pass-through. So it allows you to issue Ceph CLI commands directly, which means that if you issue a large number of those concurrently or in short order, they can affect
So if
the
you
log endpoint which goes and gets things on demand as well.
Which one?
The log endpoint. So
I'm sorry.
the thing that goes and tails the log.
Oh yes, log. That's right.
okay, well, and that's good news. Well, so are we not letting people query Smart on the fly? Actually, go down to the Ceph cluster itself and issue that command over and over again? We're having it be something consumable that we are pulling on the back end instead of something that they are actively going and requesting via the GET request, submitting a command down to the lower levels.
I think it makes sense to implement that way, because my understanding of the way that a lot of sysadmins use Smart is they just either, I think there's even a Smart D, but basically it just ends up in cron and it reports, and they look at reports, not always. I mean, I imagine in your disaster recovery, you might run it and expect to do it interactively.
So I think the main practical reason, leaving architecture aside, for not gaining it on demand is that when a drive fails, that's when you would like perhaps to know what the smart status was before it failed.
Right.
So you need to have been collecting it in the background the whole time. And at the point that you've been doing that, then you have it stored somewhere. So when the user asks for it, you don't have to go and hit the drive again. And I would echo the point you were making, Joe, about hitting the drive frequently being bad news, because while some good controllers will do that efficiently, some bad controllers will stop I/O while they go check smart stuff.
Yeah,
which you've seen.
Well, it depends on what kind of drive you're targeting too. It can be more destructive to a SATA drive than to a SAS drive, and well, in this kind of scale out environment, people are using SATA primarily for their backing storage, right?
Yep, frequently, yeah.
So I feel good on the smart data side. How do you feel, Greg?
Yeah, I think that's fine. So let's see here. So then I guess one of the thoughts that I was having...
my brain was running slowly. Can I just come back to that last bit for a second?
Yep.
The last open question on the mailing list about this was about whether the smart collection is happening in Calamari or Ceph. What's the outcome of that?
we're both leaning towards in Ceph, but there are a lot of reasons for that. Some things are still up in the air. Do you have any more you want to elaborate at this point, Gregory?
Yeah, well, I mean, I think the current direction for Calamari is going to go along the lines of what your last piece of feedback on the mailing list was, John. That Calamari is too complicated to be useful, and so in the future we're talking about paring it down so that it basically provides the REST API and doesn't have a lot of additional trappings. So kind of continuing your work in the past on Calamari on monitor. So making some of the other things that it does right now optional and trying to modularize it so it's just, it provides the smart API, not the smart, that's the wrong word. It provides an intelligent high-level API and little else. And so in that future, I mean, there's the product Calamari lives on, and it would still do something like that. But if you shed some of that functionality, then it makes less sense to say Calamari schedule salt, right? Or schedule smart via salt.
Okay, so at that stage, the smart collection we're talking about doing here is an OSD change. So are there thoughts on how that is going to work?
We're talking about a couple different. At some point, we have to abstract that away, right? Does that sit in Rados, or do we go and target some other kind of library or API that exists that's already doing this particularly well? We're throwing around a couple of options. I mean, Gregory, do we want to talk about the one that you were talking to me about earlier at this point? Bring that in as a possible buffer, a possible intermediate consumer of the smart data?
Lib storage management?
Yes, sir. Yeah. I just didn't know if we wanted to talk about it yet.
Yeah. That's a possibility. At this point, I don't have a really great answer on any of this stuff. I have this thought of direction, but as far as how to add it to the OSD, whether it's something we provide there or whether it's something we look for if it's available, I don't have a great thought on that.
So I mean, well, so that's one question. What library do you use for querying smart data?
Right.
But you also need to think about how is it going to get encoded and sent back to the Mons? Is it going to be something that is sent back periodically, or is it going to be like a tell command using the existing OSD tell mechanism? When it gets back to the Mon, what happens then? Where does it get stored on the Mon? So I think if the decision is made that this is an OSD and Mon change, that design of that should be your priority to get that right first.
Okay, that's fair. I mean, the other way we could implement it, I suppose, is just as something that's running in the background, and then you match up whatever the OSD is aware of with regard to an endpoint, a device node, essentially, with whatever you got from that device node and that smart query running in the background, hitting all the devices periodically.
Yeah, I think the part where you actually query a device is probably less complicated than the part where you have to send it home and do something with it on the Mons.
Right. I've got and at this point we can talk about what does exist today. I've got one change outstanding currently waiting to go upstream for Joule that does pull the device node, and it does pull the mount path from, it uses libblockid to go and accomplish that. Obviously the smart is heavier than libblockid's, what libblockid is doing, but it could be similar. We could put it in a similar place.
Where's that getting sent back? Is that with the boot metadata?
Yeah, but so it would have to, it's not quite just the boot metadata then, it's something more frequent, right?
Right, yeah. I mean, it could be that it was something we wanted to send on boot, but you also need the ability to find out what it is at other times as well.
Right. So that's definitely a work item that we can add, Gregory, to what you or I need to do. So beyond that, there are other things we can do beyond smart, right? We don't have to just be pulling smart data, but there are other operations that may be valuable on a controller array or on a disk, a storage endpoint of some sort. Is there anything, John or anybody else, is there anything you want to see us pulling up or querying from disks periodically that would offload some tasks that storage admins are doing today?
Is the question only about this itself, or also about the arrays or array controllers?
That's part of the other things that we're trying to think about here. Is we're going to have to abstract more than just a command line interface or an executable, right? We also need to figure out how to talk to, say, HPSSA CLI or what MegaRAID uses, for example. Those are tools that we need to interact with, and that's partially why lib storage management came into play, because it has some of the framework for that built up already. So if it satisfies our requirements, that's a direction worth pursuing, and just plugging into APIs there.
If I have it correct in mind, for example, the LSI controllers can be set up to run smart anyway on regular base and can report it then back on the drive. So you only need to call the LSI tools to get the smart information, for example, and for sure information like Is the battery for battery backup RAID controller still okay, or is it in a failed state? Would be some useful information for sure. Yeah.
Okay. And do you, in your deployment, for example, or any deployments you're aware of, are we using RAID controllers or are we using pretty much strictly HBAs?
We used
with RAID 0.
Not because everything was in RAID 0, but yeah, battery backup still, and
yeah,
it would be useful to know. I mean, I wouldn't probably buy such thing again. I didn't buy it, so but it's still there, and I guess there are a lot of people that may reuse old hardware or existing hardware, and then there's often a RAID controller in the way, so information on that would be maybe useful. The question for me is what kind of smart information you really want to collect. Is there a failure in the failure log, or do you want to collect more of the usual data that's coming from smart? I mean,
well, you can get some hints about the health of a drive from smart, right? You can get information about IOs that fail from smart, and that's the kind of thing you can track, and then you may be able to see, okay, this drive is really not behaving correctly. You may even be able to preemptively intervene and avoid more significant downtime, right?
I mean, specifically, Danny, the metric that we're interested in collecting and taking any kind of reporting action on is remap sector. Right. So the idea is the drive has the capability to mask some of that problem.
I know.
When you get to the threshold.
My question was only because most of the data that's coming out of the smart command is not very useful if you don't know what the vendor is doing, because every vendor is doing something different with these values.
True.
So, yeah.
Yeah, and to that point, I guess part of the reason for this design is to try and make it so that we can point to the parts on Calamari. So when a vendor comes along and says, "Oh, you're doing the wrong thing with our hardware. You don't know how to predict failures. Let me show you how to do it." And we say, "Well, we're collecting the data here, and here's where we analyze it, and then there's where we report it." So fix those things, and it'll work.
Well, and that's something that somebody could implement someday, right? Any disk vendor, a hardware vendor like HP, we have a lot of information about what some of this stuff means, and if that's something we can open source in some way, then maybe that's useful.
On the point about RAID controllers, if you are on a system using RAID arrays, life gets complicated in some other ways as well. So potentially somebody can, let's say they've got a 10-disk RAID 6 and they've sliced it up into 2 LUNs, and each LUN is a different OSD. And so each of those LUNs has a worldwide ID. But so does each SCSI disk within the array that both LUNs are carved out of.
Yep.
And at that point, you're going to have to come up with a schema for expressing that topology of you've got a LUN, it's got disks in, they're part of a RAID array. There's another LUN that's part of the same RAID array. That can get pretty hairy, especially trying to do it generically. So would it be unreasonable to say, actually, if somebody's using RAID arrays, their array manufacturer should give them tools for this, and the functionality in Ceph should only be for bare disks? I mean, it depends on what people are using, whether that is an unacceptable limitation or not, but it would make the Ceph and Calamari part of this much slicker if it didn't have to deal with arbitrary topologies of drives and RAID arrays and dual pathed controllers, right?
Yeah.
Well,
I do, and multipathing is a total different beast, and that's, I would say that's certainly outside of the scope of what we're expecting for Ceph. Is anybody actually using multipathing in Ceph today that we know of? So I don't know. It's something that we may have to think about. I would say that the initial scope of this should be RAID 0, single disk RAID 0, and then single physical disk. I think that could be handled reasonably easily. But like you said, when you've got a RAID 6 or a RAID 5, anything where you could possibly carve a logical volume out of a single array, it gets complicated. And maybe the right answer there too is to not try to. Let me back up a step. If you're using it in a RAID mode, then you've made a decision that you perhaps care more about the RAID abstraction on top of that underlying storage, and so maybe that's what we present. If you're in RAID mode, you get logical volumes. If you're in HBA, you get physical disks, and you just get what you've exposed at that level.
I agree.
Okay.
Makes sense.
Let's see what else we've got here. So I think the generic elements that we're adding underneath the worldwide ID or whatever we consider the abstraction to be eventually make sense. Drive, device node, what kind of disk it is, what its capacity is, manufacturer, firmware version, serial number. That's pretty much the basic stuff that you'd want to know.
You just skipped over usage, which was the one I was about to ask about.
Oh.
What do you mean by usage for a block
I
device?
didn't add usage. That's why I skipped over it.
Okay, all right.
So what's the question about usage, John?
So, I mean, if somebody was on a file system, obviously there would be a usage. But if they're just on a block device, then that doesn't mean anything.
Yeah, that's a good point.
Well, and I mean, we already today via the OSD metadata have what file system is provisioned on top of the storage. So that's something that we'll slot in there too. I was talking to Gregory about adding that to what I'm already adding to Calamari. So.
Okay, well, we can exclude it from this point because you're right, at this level of abstraction, it doesn't really make sense. Okay. So then, knowing all those attributes of this endpoint, I've thought that the right ways that you'd want to be able to filter this data would be kind of a set of four. You'd want to be able to filter out by host, by manufacturer.
One question: what would be standing in host? Is it the host name, or
Yes.
what would it be? Okay.
Would you expect something different?
Yeah, I don't know. For example, I know some people add information about the machine to the, what is it called, FRU or something like that. You could put information about the machine on, to have your own inventory information on the machine, and maybe that is something you may also want to add to the host to identify it easily instead of a host name. I mean, in a large setup, a host name doesn't mean anything, so.
That's a good point.
Also change with the next boot.
Your other option too would be to expose more like the path through the crush map where this disk lives, right?
It's about as detailed as you could get. Yeah.
I mean, that depends on the crush map being set up in a way that maps the physical reality.
Yeah.
Maybe some information from IPMI or something like that would also help.
Yeah, and that's kind of another stretch goal for what we're doing here. It's not there is other hardware in this environment that's not just storage disk based, and IPMI is a great way to get at that. There are other future looking tools too. If you want, you can go and look up what Redfish is. There are a bunch of other vendors collaborating on BMC capabilities outside of just the basic IPMI.
Yeah.
Set of data. That's all stuff that, when I approached this project, that's stuff that from HP's perspective we do want to bring in here, if it makes sense.
I think it's how to phrase this. It's very easy when writing a storage management tool to end up writing a data center management tool. I'm not sure that we really want Ceph to monitor your power distribution unit.
That's fair, yeah, and that's probably, you're right, there are places where this would stop, I agree. Figuring out where the right place is part of that.
I mean, it's open to debate, of course. One idea that I've had is things which are on the I/O path are Ceph's business. So the block device is Ceph's business. The network card potentially is Ceph's business.
Sure.
The supporting infrastructure, probably less so, and the Linux hosts themselves. Presumably most environments have some other tool that's monitoring their estate of servers. I think we should be mindful that Calamari and Ceph are not the only things running on these systems, that any normal administrator will also have deployed their site-wide monitoring tools that they use for all their servers.
Yeah.
That's a little bit different if somebody's building like an appliance set in that world, then they would probably want something much more all-encompassing. But for a general purpose Ceph monitoring tool, I think as a starting point, maybe we should limit it to I/O devices.
Yeah,
I think that's a good point, and I think that you're right about that. One future direction of Calamari is definitely to be the answer about what's going on, from Ceph's perspective to those larger monitoring frameworks. Right? So we're just sitting there alongside as peers of other things about hosts, data center, management, and all that we don't want to get our fingers into. We want to just be offering the best opinion we can about what's going on with the Ceph and the I/O.
Yeah, exactly.
Somebody's presenting something. No? Okay. Well, I think we're out of time, Gregory.
Yeah, I think so. We, of course, I have another session about Calamari right after this, so if you guys are really interested in talking, I'll steal from my own time.
I think I got the answers that I needed, and especially about scope of what we're doing here. I think we still have some decisions to make about whether we plug into some other more general purpose tool that's already implemented around some of the other tools that we're trying to include here, Smart, HPSA, CLI, etc. That's all still TBD, but I think we have a pretty good start on what the right answers are to look for.
Okay, I agree that the shape of the data hasn't shocked or surprised anyone.
No.
So we'll probably go forward with that.
Great.
Cool. All right.
Is anyone sort of taking on the work of doing the OSD and Mon side of this?
That would probably be me, Joe.
Awesome.
All right. Are we all set then, Gregory?
Yeah, let's go ahead and halt the recording.
Right on. Awesome. I'm getting a recording error. We're going to be recording forever.
We broke it.
Yep. We totally did.
At least it's on our session, right, Gregory?
I don't know if I want to be remembered that way.
It's not our fault. We just got to reap the benefits.
Awesome. Well, why don't we go ahead and start the next Calamari session, and we'll be all in one single video here. I can just time code link it.
Great. Okay, the next session about Calamari has the fun title, Let's Make Calamari Easier to Troubleshoot. So I can say that about this topic, myself and I know John, who does a great job of participating in the Calamari mailing list, spend a large amount of time helping other people troubleshoot Calamari. And I don't think that's really the best use of my time because I want to make Calamari better and I want to have time to write features. So this session is really about some ideas I've had and some ideas maybe the community has about how to improve that interaction and how to get past the trouble, overcoming the difficulty of getting Calamari set up. So I think something that's going to go a fair amount of distance in that is having offered packages for Calamari on download.ceph.com, because so far the conversation when setting up Calamari is usually, okay, where do I get the packages? And until now, our answer has been, well, you've got to build them yourself. So in the future, that's less the case because we're offering them. And going forward, I hope to improve that to the point where it's not even a question about where are the packages for my distribution. So we should have broader coverage. And then the next topic that inevitably comes up is, okay, tell me about this salt thing, because salt is causing me problems.
I will second that one. Yep.
So the class of issues that we usually have with salt is that people are usually running versions that are far too old, or unfortunately in the recent case, far too new. So 2014 anything is a pretty good bet for salt, and all the other versions cause us trouble. So to that end, I've included in the docs that bit, and I've engaged the salt community to work on what's causing us trouble with the latest versions. I don't know that we're going to see any relief for 2015 5.0, 1, and 2, but I have it from them that they're going to be doing something about zero RPC in the next version or in the future that may cause our no sleep decorator to stop complaining. And we've also discussed internally about maybe relaxing that in some way.
So the underlying issue that you're having with salt is that Calamari uses non-stable APIs and behaviors in salt. So, some of the method names it calls start with an underscore. And as long as that's the case, new versions of salt are going to keep breaking Calamari.
There's that. And I think the discussion right now is really more about the trouble of getting salt set up and the troubleshooting steps that go something like, I've installed salt, I accepted some hardware into my cluster, I've accepted some minions to the master, then proving that transport, the 0MQ transport, is actually functioning, and then finally proving that Cthulhu is able to do meaningful work on the Ceph cluster. So I agree that the non-public interfaces is a problem, but in order to make Calamari easier to troubleshoot, that's kind of low on the order of, I care about that right away, because most of the time it's just, well, okay, what does salt key -L tell you? What does salt star test ping tell you? What does get heartbeats tell you? I feel like I say that a lot, and one idea to solve that is to include it in the troubleshooting doc.
Okay, so if I understand you correctly, you're saying that rather than working with the latest versions of salt, necessarily it's about having a tool that tells you whether you're using a supported version. Is that
No, I'm trying to say it's not about that. I do want to work with the latest versions of salt. And there's another problem, which is people just understanding at what point in the stack the problem is. When they say, help, my Calamari node is not giving me updates to the cluster, or it never recognizes the cluster. And yes, working with the latest version is part of that, but it seems like a lot more of the problem is the understanding that if you haven't connected them properly, or any other thing that can go wrong in that setup, finding out how to pinpoint that. And so what I'm proposing is a set of steps that say, try this, then try this, then try that. So I think the two different discussions.
Okay, fair enough.
I'm saying one versus the other. So definitely where I want to start is improve the troubleshooting doc, and then on the mailing list I want to start pointing at that troubleshooting doc every time that I get the itch to say, well, just try this or just try that.
I think that would get you a long way, Gregory. I've seen it from the time that I've paid attention to what's going on in Calamari. Just there's some errors that come back that are not obvious. It comes back from this Python file, but it really has nothing to do with this Python file. It's really what Salt's doing 5 layers up or something, or what Cthulhu's doing somewhere over here. And so really knowing how to go back all the way back to where the problem might be via your experience in debugging this sort of thing would probably help a lot of people, myself included.
Yeah, I feel like too long I've been guilty of just synthesizing some troubleshooting steps and one-offing it each time, when what I should be doing is improving the docs and always pointing at the docs. Because if they can't help, then it's on our shoulders or my shoulders or anyone who spends time on the mailing list to come up with solutions every time.
Right, I agree.
I want to say that's definitely one work item for this, which is improve the doc troubleshooting section.
Maybe the easiest one. And I don't know, is there, you've hinted to it in making Calamari lighter weight, but that is part of the difficulty in it, right? There are these other pieces running around, be it Salt or some other piece of Python code that's come in, and really understanding what the right answer is to debug all those different little pieces, or finding some way to remove them if at all possible, right? Remove complexity, make it easier to get down to the core of the problem.
Yeah, that's fair to say, for sure. I can say that from the project standpoint, that's a viable solution. I can reduce the complexity, and from my day job standpoint, the product that this is based on isn't going away. So it looks like I'm going to be supporting that. So the good news is that we have a lot of flexibility with what Calamari can become. I've still got to figure out how to spend less time dealing with the frustrations of Salt and some other problems with Calamari. So to talk about the other issue, John, yeah, that is another work item, which is make it so that we're only relying on the public API of Salt, or the public methods of Salt.
Yeah, and I would sort of echo Joe's comments as well. That, I mean, it may very well be that there's this sort of tactical need for an improved ability to troubleshoot the system, but the long-term goal should be for the system to require less troubleshooting.
Yeah, that's fair to say.
And yet there will always be poor, so having both is a great idea long-term too.
I think we're making a little bit of progress towards getting away from the underbar prepended APIs, the intended to be internal APIs of Salt. That was what happened with that one Salt loader issue that I submitted that pull request for. It just didn't translate to the new bit that was in 2015. Now, unfortunately, it turns out that 2015 has problems that we have to backpedal from, so we can't really fully migrate over to that. But we're trying.
Yeah, so this is actually a great transition since we've got all the right people here, which is John. Joe had asked the question a little while ago, which was, what was the original motivation for the No Sleep Decorator, and have we ever captured any issues with it, or is it just there because it makes us feel good?
It's not just there to make us feel good. It's not even there to make us feel good. So basically, you either need some locks around the various places where we dispatch incoming events, so that things don't trip over each other.
Right.
Or since we're using G-event, and there isn't actually any parallelism going on, it's a single thread. Because of the way Salt happened to work at the time the code was written, it was possible just to essentially not bother with any locks. But in order to make that safe and make sure that we weren't, introducing bugs by doing that, the no sleep decorator was something designed to sort of, it's basically an assertion that
deadlock potential.
It's an assertion that it's safe not to lock. And at the point that the salt code changes to introduce sleeps in the IO calls, the no sleep decorator is doing its job. It's telling you, actually, no, you do need a lock. Okay. I mean, your path forward there probably is just to look at the entry points where we receive events from Salt and go process them, and make sure that the the whole operation that we do as a result of receiving a particular event happens atomically within probably within a lock.
Right. So your guidance there would be to reintroduce some of the locking.
But very specifically to get this behavior of holding the lock for the duration of processing a particular event coming from Salt. So I'm not talking about going through all the data structures and adding lock members to them and that kind of thing. I'm talking about you get an event from Salt, you take a lock, you deal with it, you drop the lock, so that it doesn't proliferate through the code, and so that Thulu itself remains essentially a single-threaded event loop, rather than trying to introduce a whole bunch of parallelism there. Unless in the future parallelism is needed, in which case, introduce it, and then the locking gets more complicated.
Yeah, well, and we're talking mostly about reducing complexity, so right. At the moment, we don't want to do that.
Yeah, exactly. Keep it down to a nice, simple event loop.
Okay, well then, I mean, that's pretty easy. The idea there being that we have the no sleep decorator to guide us, essentially, that we've got the locking correct. So it's my understanding that if we put the lock around the event handling code in the right way, then it'll sort itself out and we can leave that decorator where it is. Does that sound right?
Yeah, it's a canary, basically.
Okay, great. So there's that thing too. I mean, those are kind of the large themes of what's wrong there. I mean, some of the other stuff that comes to mind is the large amount of dependencies, which comes in with what John asked last time when we talked about Fedora packaging. We have a bunch of bundled dependencies, and so another goal to make that easier is to unwind some of that, so that we're able to deal with more of the world and not just our specific versions that we like to ship. Because that seems to be kind of we have this perfect notion of it works with these things, and if we never change those, it'll continue to work. But that's not going to go so well, because so far in the community, we offer up this guidance, and then lots of people want to install it in different places, and so they end up experiencing things that we don't usually test with because they have slightly different versions of this, that, or the other. So supervisor is one package that comes to mind. We don't call out any explicit dependency on a version of supervisor, yet there's a version of 2 that shipped in CentOS 6 that fails to let Thulu do its job. It just hangs totally. So do we have any thoughts about that?
So I have 2 comments, a short one and a long one. The short one is that there's a piece of low-hanging fruit here, which is to get the diamond changes upstream. There's nothing wrong with that code. It just needs someone to take on the task of upstreaming it. The longer one is that in order to make sure that things aren't breaking with new versions as they come out, the development of Calamari has to happen on the upstream distro. It has to happen in Fedora. So going and doing packages for Fedora is absolutely the right thing to do. But what that means is you've got to be potentially testing it against Rawhide. So that at the point that people make a change to Supervisor or Python or ZeroMQ or whatever it is in Rawhide, you know about it and you can send them an angry email and you can fix it before Fedora gets released, right? Because once the distro has been released, you can't change the other packages and you end up having to have workarounds. But if you're developing right at the bleeding edge there, then you can ensure that breaking changes don't go into the distro, and you can object to things on the basis that, hey, my package depends on ZeroMQ. These guys made a change that broke it, and potentially they have to back out their change rather than you having to make a workaround. And that certainly requires a lot of work, but that's sort of the ideal way of doing it.
Yeah, and I support that's kind of where I want to go, is the idea that if we make it so that the development environment works on Fedora and there's packaging available, like honest packaging available on Fedora, then we can be part of that discussion instead of always reacting to well, this thing changed and now we've got to deal with it. Because our previous answer, which wasn't so great, was we also were very sensitive to version. We said, well, the way we'll solve this problem is henceforth never use anything but this working version. But that's just a time bomb, and it's been biting us for a while. So I want to change direction.
The one place that falls down, just thinking it through a little bit further, is when people are using other third-party packages. So if people are getting their Salt packages from salt.com instead of from Fedora, then even if we're being really good upstream citizens, they can still break us. And that's probably another good reason to move away from Salt, unless it becomes a more ubiquitous part of the upstream distros.
Well, we got about 8 minutes left. Open it up. Does anyone have any pet peeves about installing or setting up Calamari that they want to be heard or offered solutions for, or just some commiseration?
Well, I found out yesterday that some of the testing framework requires tautology, so now I've got to go set that guy up too.
Yeah, it doesn't necessarily require tautology, but the answer there is tautology makes it a lot easier, because to test Calamari, it requires that you want to either have a simulation of what a Ceph cluster is or a working Ceph cluster with which to test against.
And the simulation should still run completely independently of tautology, right?
Yeah, that's right.
I think the minion sim does. That's fine. I just went and ran some of the testing framework. I think some of the things in tests itself, and I was just like, oh man, did not expect that YAML file error. Guess I've got to go set this up if I want to run the whole test suite.
Yeah, actually,
test.conf.
Yeah, that one. No, it's not testing conf. It's
No, I'm saying you need to set up that test.conf so that it doesn't try to do an external cluster, because testing against an external cluster, yeah, you probably want tautology. But if you're not testing against an external cluster, if you just want to test Calamari itself, there shouldn't be any requirement for tautology.
Okay, well, I thought about writing that up as an issue, and I didn't, because I just thought I was doing something wrong. But I can go and specify exactly what I did that caused that, so we just have it tracked.
There could be a bug, yeah.
Yeah, go ahead and file it, because like Dan said, there should be 2 independent paths, which are you can simulate the Ceph cluster or you can have a real one. Both have their advantages. One's easier to set up, and one gives you more realistic simulation. It's not simulation.
Yeah.
Wrap it up.
I think we're ready to wrap this one up.
All right, cool. Let's see if the video will let me kill it.
And thanks, everyone, for your input and questions.
All right. Looks like we're still having issues. So, Evo, before we get into yours, I'm going to drop and re-add here. Hopefully it won't kick everyone out. Be right back.